Good day everybody, we got a beautiful question. Foremost, I will have to draw the all-important circle. Now, I need to draw a quadrilateral inside the circle. So since I have a point here, let me take this point and let me place in the center for the circle. Now the quadrilateral is hitting a point here, so let me connect this point and then there is a hit over here. So let me connect these 2 points. And then there is a hit over here. And then finally, so I'm going to name these points as A, B, C, D. This point is O. Now from D, I should say from O there is a line to D. Probably I could have drawn this a little better. Okay. And we are asked to find the area of the following figure. Now let me just draw that figure. I need to be a little bit careful in drawing this. And okay, so we need to find the area of this figure. We need to, it's a triangle, we need to get the area of this triangle. Okay, foremost, let us make the following observation. Now you can pause the video and try this question and see if you're getting the answer as given here, and also make sure to place in your comments. I would like to know what do you think about this question. Right, so foremost, let us make the following observation. A, B, C, D is and one more important thing, we've been given this thing to be at 90 degree. There is an angle here, so that is given. Now let's start. ABCD is a quadrilateral with all its vertices being on the circle. Okay, this means ABCD is a cyclic quadrilateral. Okay, that's the first observation. Observation number 1. Now, for a cyclic quadrilateral, the sum of the opposite angles is equal to 180 degree. Now, since angle B is equal to 90 degree, this means angle D is also equal to 90 degree. So angle B plus angle D is 180 degree, right? That's the second observation. Now we are also given that BC is 2 units, right? So 2 units, and AB is root of 12 units, given that BC is 2 and AB is equal to root of 12. So these two informations are given. Now, after this, I would like to apply the Thales theorem or Thales theorem. Now, what does the theorem says? If C, D, A are distinct points on the circle, and so clearly we know the angle at D is 90 degree, right? We know that. So if C, D, A are distinct points on the circle, and angle at D, if it is equal to 90 degrees, you can either state it as angle at D, or you can state it as CDA is equal to 90. It's up to you. So since angle at D is 90 degrees, so let me start it. If C, D, A are distinct points on the circle and angle D is equal to 90 degree, then AC should, or AC is the diameter of the circle, or you can simply state should be. If you don't want to use should be, you can say simply state it as AC is the diameter of the circle, right? So this is by Thales theorem or Thales theorem, however you want to pronounce. So diameter is a line that is passing through the center. Now there is already a shape which we have been given, and that is hitting the center also. What I wish to do is I would like to connect all of this line, and right, so this is what we've got. Now we need to know this part, right? Now before we could go to this part, what I wish to do is I would like to consider the triangle ABC. Now why am I considering? I want to find out the radius. Okay, let us find out the radius. To find the radius, R, let us consider triangle ABC. Since it is a right angled triangle, what can we do? We can use Pythagoras. So by Pythagoras theorem, we get So what do we get by Pythagoras theorem? AB squared plus BC squared is equal to AC squared. My AB squared is root of 12 raised to the power of 2 plus my BC squared is 2 raised to the power of 2. AC I don't know, so just simply place AC squared. This is 12, root 2 squared is 4, this is equal to AC squared. So AC squared is equal to 16, so AC is equal to root of 16, which is equal to 4. So my diameter is 4 units, so this part is 2 units and this part is 2 units. So this means OC is equal to OA is equal to 2, right? Now you have to understand one important thing. Excuse me. That important thing is the diagonals of a cyclic quadrilateral, they intersect at 90 degrees. So this intersection is actually 90 degree. Okay, have that in mind. Now another important point you have to know, that DB is the angle bisector. The line DB will be dividing the angle here into two equal parts. That's the understanding. So clearly this angle, this is a 90 degree, this will be divided into two parts. So definitely we can take this part to be as 45 degrees. I'm utilizing this triangle, right? Now as I mentioned to you, the diagonals of the cyclic quadrilateral, they intersect at 90 degrees, so this is going to be 90 degree. Now this entire length is 2 units, right? Now what I wish to do is, I would like to get the length of this distance, right? So what I wish to do is, I would like to make it as P there, that intersecting point to be as P, and I would like to know what is PC. Now for that, what I wish to do is, foremost I would like to apply the cosine ratio. So let me go to this page and consider triangle BPC. I'm considering triangle BPC. Cos 45 is adjacent side divided by hypotenuse side, right? So my adjacent side, I don't know, I take this as x, but my hypotenuse side is 2 units, but cos 45 is 1 over root 2. So we get 1 over root 2 is equal to x over 2, and we need x. This means x is equal to 2 over root 2. 2 can be written as root 2 times root 2, that has to be divided by root 2. So therefore x is equal to root 2. Now this distance PC is root of 2. Now this entire, as I mentioned to you, this entire length is 2 units and I want OP. Now to get OP, what is OP? OP is nothing but from 2 you subtract root of 2, right? This entire length is 2 units. From 2 you take away root 2, you get this. Now what we are going to do is, we are going to consider triangle OPD. Consider triangle OPD. Now you have a 90 degree here. As I mentioned to you, the diagonals of the cyclic quadrilateral, they intersect at 90 degree. Now as I mentioned to you, I have got this value. What is this value? This value is nothing but 2 minus root 2. OP is 2 minus root 2, and I know the radius. You see that? OC is equal to OA is equal to 2 units. So from the center, a line is drawn to the circle. That's going to be radius. So that's 2 units. So applying Pythagoras theorem, we get. So what is the theorem here? I need to actually get the height. right? The 90 degree side I need to get. So OP squared plus PD squared, OP squared plus PD squared is equal to OD squared, So my OP squared is 2 negative root 2 squared. My PD squared we got to find. My OD squared is 2 squared. So this is 4 negative of 2 minus root 2 the whole squared. So it's equal to 4 minus of, expand this. This is 4 negative 2 into 2 times root 2 and then positive root 2 squared. So it's going to be 4 negative 4 positive 2 times of 4 times root 2 and negative root 2 squared is 2. So negative 4 positive 4 goes off, giving me 4 into root 2 negative 2. So this is going to be my PD squared. So therefore PD is equal to root of 4 times root 2 negative 2. Right. So this is my PD. Now we need to get the area of this triangle. Right. So therefore required area is nothing but area of triangle. What is that? OPD, which is equal to half times base into height, which is equal to half times my base 2 negative root 2 and my height. What is my height? My height is given to be as root of 4 times root 2 negative 2, and this is the answer, square units. So please go through this solution and give your comments. Thank you everybody. Like, share and subscribe to our channel. Enjoy your night.